Hello everyone, I am Rampavan. Welcome to this video of closure properties of CFL. CFL means context-free language. Introduction. Context-free language is generated by some context-free grammar. The set of all context-free language is identical to the set of languages accepted by push-down automata. Context-free grammar is defined in four tuples: capital V, sigma, P, S, where capital V is set of all variables, sigma is set of terminal symbols, capital S is start symbol, capital P is production rule. Types of properties: union, concatenation, cluster, intersection, complement. Let's go to these properties one by one and see whether the context-free language is closed under these properties or not. Union. Let's take a language L1 of a to the power of n, b to the power of n, where n is greater than or equal to 1 via a context-free grammar. G1 has tuples of v1, sigma, p1, s1. The production rule p1 is s1 gives a s1 b or s ab. This language basically tells that number of A's and number of B's are equal, where all the number of A's are came, then only the number of B's can come. Now take the language L2 is C to the power of m, D to the power of m, where m is greater than or equal to 1 via a context-free grammar. G2 has tuples of v2, sigma, p2, s2. The production of P2 is S2 gives C S2D or CD. Then the union of those languages L1 and L2 is A to the power of n, B to the power of n, union C to the power of m, D to the power of m, is also a context-free language via a context-free grammar of G has tuples V, sigma, P, S such that S gives S1 or S2. This production will be added to this union of L1 and L2's productions. Concatenation. Let's the language L1 is A to the power of n, B to the power of n, where n is greater than or equal to 1 via a context-free grammar of J1 has tuples P1, sigma, P1, S1, where the production P1 is S1 gives AS1, P or AB. Language L2 is C to the power of m, D to the power of m, where m is greater than or equal to 1 via a context-free grammar of G2 has tuples V2, sigma, P2, S2, where the production P2 is S2 gives CS2D or CD. The language L1 says that the number of A's and number of B's are equal, where all the number of A's are appeared, then only the number of B's can come. Where in the language L2, the number of C's and number of D's are equal. When all the number of C's are appeared, then only the number of D's can come. Now if we see the concatenation of the language L1 and L2 is A to the power of n, B to the power of n, C to the power of m, D to the power of m is also a context-free language via a context-free grammar of G has tuples V, sigma, P, S such that the production of capital S gives S1 concatenation of S2. This production will be additionally added to the given language's productions. Clean star. Let's take a language L1 of a to the power of n, b to the power of n, where n is greater than or equal to 1 via a context-free grammar of G1 has tuples V1, sigma, P1, S1, where the production of P1 is S1 gives A S1 B or AB. Now if we see the clean star of this language L1 will become L1 star will be equal to a to the power of n, b to the power of n, whole to the power of star. This will become the clean star of the language L1, which is closed under the context-free language given and via a context-free grammar of G1 has tuples V sigma Ps such that the additionally added production will become capital S gives capital S, capital S1 or epsilon. So Clinster is closed under the context-free language. Intersection. Let's take a language L1 of a to the power of n, b to the power of n, where n is greater than or equal to 1 via a context-free grammar of G1 has tuples V1, sigma, P1, S1, where the production P1 is S1 gives AS1, B or AB. This language basically tells that the number of A's and number of B's are equal, where first all the number of A's are appeared, then only the number of B's can come. Now if we see the language L2, which is c to the power of n, t to the power of m, where m is greater than or equal to 1 via a context-free grammar of G2 has tuples V2, sigma, P2, S2. And the production of this language is S2 gives CS2, D or CD. Then the intersection of these two languages will become AN, PN, CN, DN, which is not closed under the context-free language. It is because the pushdown automata can only compare the languages, whereas in this condition, the intersection says that the PDA should satisfy those two languages. So the pushdown automata is not satisfied, hence the context-free language is not possible to this intersection. Complement. Let's take a language L1 of a to the power of n, b to the power of n, where n is greater than or equal to 1, and the language L2 is c to the power of m, d to the power of m, where m is greater than or equal to 1 are closed under complement. Now if you take the union of the L1 and L2 and apply complement, then L1 it becomes L1 complement intersection L2, and this will become L1 intersection L2. This is because we have already said that L1 and L2 are closed under complement. So we can directly write L1 complement as L1 and L2 complement as L2. As the L1 union L2 is already closed under the context-free language, if we apply the complement to that union of L1 and L2 gives the L1 intersection L2. By applying the complement, it says that L1 intersection L2 is closed under context-free language, which is the contradiction that we have said before. The L1 intersection L2 is not closed under the context-free language. So hence from this we can tell the complement is not a context-free language. Conclusion. Union is closed under the context-free language. Concatenation is also closed under the context-free language. Cleanster is also closed under context-free language. Intersection is not closed under context-free language. Complement is also not closed under context-free language. Thank you for watching this video. Do like, share and subscribe my channel.